This video briefly introduces our research on the wideband filtering antenna with small footprint based on non-uniform grid array structure. Recent advancements in 5G and emerging 6G technology have highlighted the need for compact wideband antennas in space-limited systems, such as miniaturized mobile terminals and IoT applications. Among the numerous proposed solutions for bandwidth enhancement and multifunctionality, the grid array antenna stands out due to its low sensitivity, small transverse size, low profile, and ease of integration, making it a promising candidate for on-chip systems, aperture shared arrays, and high-integration mainboards. Compared with conventional microstrip patch antennas, the grid array antenna inherently exhibits the advantages of closer multi-mode operation and size reduction. The proposed antenna was developed from a conventional grid array. Through two stages of evolution, bandwidth enhancement, radiation property modification, and the introduction of a filtering response were achieved. In the bandwidth enhancement mechanism, the conventional grid array operates at TM10, quasi-TM02, and TM12 modes. The antenna was then redesigned with a non-uniform grid structure, combining the first two resonance modes. To further extend the bandwidth, 6 horizontal slots were etched into the grid, shifting the third mode into the band, ultimately achieving a wide operational bandwidth of 18.8%. In the radiation property modification mechanism, the local meander path in the grid guides the current to flow in the X direction, enabling the non-uniform grid antenna to naturally support radiation modes M1 and M2 with the same polarization. Subsequently, in the second stage, the introduced L probe is divided into 2 open-ended strips by its connection point with the grid. This division ensures that the currents on the L probe and the adjacent grid become even symmetric, which eliminates their contribution to bore site radiation. As a result, the proposed antenna design achieves 3 resonance modes with excellent consistency in radiating direction and polarization. In the filtering response introduction mechanism, the phase of the radiated electric field vectors reverses at the first radiation null, indicating that the generation mechanism of RN1 is cross-coupling between 2 adjacent TM modes. The current paths formed by the introduced L probe and slots can be regarded as 2 parallel open-ended stubs corresponding to the second radiation null. Notably, these 2 radiation nulls can be adjusted independently. The proposed non-uniform grid array antenna was fabricated and tested, demonstrating that the measured results align closely with the simulated values. As shown in the table, the proposed antenna offers several advantages, including a single-layer structure, compact footprint, wide bandwidth, high bandwidth-to-volume ratio, and integrated filtering function compared to other designs. This proposed design provides significant benefits, making it highly suitable for various space-constrained platforms in wireless communication systems.